Good morning, everyone. My name is Philip Andrew J. Uy from the section 3MM, and I am here to teach you about derivatives. So, first of all, what is a derivative? So, as you can read in this slide, a derivative's definition can be approached from two different ways. It can be approached in a geometric way and in a physical way. So, a bit of background in the history of derivatives. Actually, up to this day, there's really a huge debate going on what should really be the approach on the definition of derivatives. So, what are the various applications of derivatives? In this slide, you can see um, many ways on how we can apply derivatives, but these are just a few ways on which we can actually apply derivatives. So linear approximation, rectilinear motion, planar motion, related rates, optimization, applied rates of change, and geometry. So it involves, we can use derivatives to solve for the volumes of several um, figures, to solve for the area, and in applied rates of change we can use derivatives to find out, for example, the rate of change when it comes to uh, money, or the rate of change when it comes to um, decreasing or increasing, let's say, bacteria or population and things like that. So why do we need to study derivatives? So as we have defined a while ago, derivatives, when we talk about derivatives, we talk about change and rates of change. And as we know, our world is a constantly changing world, and the only thing constant in this world is change. So it only seems fitting that we study derivatives, because derivatives, like I said a while ago, talks about change. So what mathematical skills are needed in order to solve derivative problems correctly and more efficiently? So, of course, we need to know about, um, actually, derivatives involves calculus, and in calculus, to be able to understand calculus, you need um, previous knowledge about algebra and trigonometry and statistics and things like that. So basically, mathematical skills we require are algebra, geometry, and all the basic stuff. So let's talk about one problem which involves derivatives. So here we talk about sales. So the shipments of the Leica digital single lens reflex cameras, or SLRs, are projected to be 6t squared plus 200t plus 4 square root of t plus 20,000. And the value of t must be greater than or equal to 0, but less than or equal to 4. So units t years from now. How many Leica SLRs will be shipped after 2 years? At what rate will the number of Leica SLRs shipped be changing after 2 years? So let's look at the given. We were given 6t squared plus 200t plus 4 square root of t plus 20,000. So the first question was, how many Leica SLRs will be shipped after 2 years? At what rate will the number of Leica SLRs shipped be changing after 2 years? So let's first talk about the first question. How many Leica SLRs will be shipped after 2 years? So it's pretty basic. We just have to look at the first equation, then set t to 2, because t is the number of years that we need to find out the answer to. So basically, we just need to plug in the value 2 into t, because t refers to the time, which is 2 years. So we just need to substitute here the value 2, as you can see, and then just compute for the answer, and the answer will be 20,829.6568542494923802. So basically, we know that there is no we cannot have decimal points in our answer because we cannot have a fraction of a Leica SLR. You can't have a fraction of a camera that will be shipped. So that's why we will round this off. So the answer would be 20,830. So the next question, at what rate will the number of Leica SLRs shipped be changing after 2 years? So this problem's a bit complicated. You need to know how to get the derivative of the original equation so you can substitute 2. So first, basically in this equation, we only have to use the power rule and the constant rule for the derivatives. So first, in getting the derivative of this, we just need to, the answer would be 12t plus 400 plus 1 over square root of 2t. So how did we get this? First, 6t squared. So in using the power rule, 6t squared, you will just get the power, which is 2, and then the answer will be 12t. And then here we get the power, which is 1, we multiply it to the constant, and subtract the power of the constant by 1, so the answer would be 400, and same goes with the third one. The answer would be 1 over square root of 2t, and then we have a constant which is 20,000. We have a constant which is 20,000, and that would be equal to 0. So here we get the derivative, and then we simply have to plug in the value of 2 to get the rate of change, which is 424.5. So basically, answering the question, 20,830 Leica SLRs will be shipped after 2 years, and the number of Leica SLRs will be changing by 424.5 after 2 years. So thank you for listening. Till next time, goodbye.